All right, Unit 5, Video 1 is all about exponent rules. So, as it says, in the expression a to the power of n, a is called the base, and n is called the exponent or the powers. All right, rule number 1, multiplying. You must have the same base, and what you're doing is you add the exponent. So here is the formula. You see a base to the power of m times a to the power of n equals a, or whatever that base is, to the power of m plus n. So down here we have an example. X squared times x to the 5th equals x to the 7th. Rule number 2, dividing. Again, you must have the same base, and you're going to subtract the exponents. So here it is, a to the power of m over a to the power of n is equal to a to the power of m minus n. And down here you have an example. R to the power of 8 over r to the power of 3 is equal to r to the power of 5, because 8 minus 3 equals 5. Rule number 3, power to a power. You multiply the exponents. So here's an example of what you see. A to the power of m to the power of n on the outside of the parentheses is equal to a to the power of m times n, or mn. Down here there's an example. You see here y to the power of 3, and on the outside of that is a 4. So you're going to multiply that 3 times 4, and you get y to the power of 12. Rule number 4, power of a product. Exponent applies to each factor, like in distributing. So here we have a to the times b to the power of n equals a to the power of n times b to the power of n. Okay, down here is an example. We have outside parentheses that raise to the power of 4 with a 2c inside. So your final answer is 16c to the 4th. I get there because I had 2 to the power of 4, c to the power of 4. 2 to the power of 4 is 16. All right, rule number 5, power of a quotient. Exponent applies to each factor, like in distributing. So over here we have a over b all raised to the power of n. That is the same thing as a to the power of n over b to the power of n. The example that goes with that, up here you see we have in parentheses 5 over w raised to the power of 3. That now equals 125 over w third. The reason being is because in the in-between, you get 5 to the power of 3 over w to the power of 3, and 5 to the power of 3 is 125. Rule number 6, power of a negative quotient. Exponent applies to a numerator and denominator, like distributing. This will cause everything inside to switch places. Okay, so here we have a over b raised to the power of a negative n. Thus, if we just do the first step, we get a to the power of negative n over b to the power of negative n. We don't like negative exponents, so we switch them. And then we get b to the power of positive n over a to the power of positive n. The example that goes with that, we have x over 5 to the power of negative 2. So here we get just simply x to the negative 2 over 5 to the negative 2. So we switch them, switch their locations, 5 to the positive 2, x to the positive 2. And then I go ahead and take it one more step. Well, I know that 5 squared is 25. X squared stays there. Rule number 7, negative exponents. Moving the exponential factor to the denominator creates a positive exponent. So kind of like the one we just did, here we have, and there's 2 of them, a to the power of negative n is the same thing as 1 over a to the power of the positive n, or 1 over the power of a to the negative n equals a to the positive n. The example down here says we've got 3 times x to the power of negative 4. Well, the x has the negative exponent, not the 3, so it needed to go to the downstairs. 3 stayed on top, so your answer was 3 over x to the positive 4. Rule number 8, zero exponents. Any number or variable that has a zero exponent is always equal to 1. So to show you why, here you get your am over a to the m. So of course we know we would subtract those. Those equal a to the power of 0, which equals 1. So this always, 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 anything to the power of 0 equals 1. Here's an example problem. X to the power of 0 over 4 is equal to 1 over 4. And the other thing we need to know in this unit for video 1, changing a radical expression. So we're going to go back between exponential and what is called radical expression. We're going to go back and forth with these. A radical expression can be written using exponents by using the following procedure. So here we have the nth root of a, okay, so we don't know what this value is equal to a to the power of 1 over n, okay? And down here I put, just make sure you have this in there, where n is a non-negative, n can be any index. So in other words, as long as a, is a non-negative, this is a positive, then n can be anything. When a is a negative, this value has to be odd. Okay, so here's an example. Square root of 7 in exponential form can be written as 7 to the 1/2. A little more involved to this problem. You have the third root or the cube root of x to the 4th times y is equal to, keep in parentheses, that x to the 4th times y raised to the 1/3 power. Getting even more complex. We have the 9th root of 3x plus 7z to the 4th power is equal to 3x plus 7z to the 4th power, all raised to the power of 1 over 9. A little more on the simplistic, we have 15 to the 1/2 is otherwise known as the square root of 15. B to the 1/3 is equal to the cube root of b. Okay, so here's just seeing it in just pure letters, so pure variables. You have the nth root of a to the m power is equal to, you see it here, the nth root of a with the m on the outside, which equals a to the m over n. So an example of what that looks like, b to the 2 over 3 is equal to the cube root of b squared. So notice how they're changing positions here. That 2 over 3, the 3 becomes the root, the 2 stays there as the power. And a way more complex one with that, we have 8x squared minus 9y, all raised to the power of 7 over 3. So down here, then we have the 3 is what the root is, so the denominator becomes the root of the 8x squared minus 9y. So you're just leaving all of that in there underneath the radical there, all raised to the power of 7 because you had that 7 up there. Okay?